I'm Wesley Yung. I'm a product manager at Astera Labs.
I'm Ternullo, Senior Director of Product Management for IP at Rambus. Today, we'll be discussing the benefits of PCIe switches and use cases. A PCIe switch is based on multi-ported connectivity between a single host or multiple hosts and interconnected PCIe endpoints to enable scale-out and accessibility to more endpoint resources. From a scale-out perspective, a host can connect to a switch and access additional compute resources through multiple endpoints connected to that switch. The PCIe switch enables connectivity of many different endpoints like GPUs, SSDs, and NICs to the host via the lower latency PCIe technology.
There are two major unique challenges within switching that I can think of. The first one has to do with heterogeneous traffic flows. Best way to imagine this is you have a lot of different traffic sources, NICs, SSDs, GPUs, and CPUs. Now imagine they're all sort of different sized vehicles trying to make their way through a traffic circle, the traffic circle being the switch. The switch has to be able to manage the types of traffic from each of these individuals, these vehicles, large cars, small cars, buses, and they have to make sure that each of these vehicles can get to their destination in a timely fashion without any kind of stalling due to the fact that these traffics are different. That makes for a very unique challenge within PCIe switches. The second one actually has to do with multi-tenancy. That has to do with companies today trying to use the same hardware, but with multiple customers sharing that hardware. This allows them to divide up their hardware in a way that allows many customers to use at the same time. This multi-tenancy means that these switches that perform centralized resources need to be able to share these things, but provide permission control so that these customers do not feel like they're sharing the same hardware. PCIe features such as access control services provide that kind of functionality and enable PCIe switches to enable essentially multi-tenancy applications.
Two of the biggest benefits of using PCIe switches are accessibility to more endpoints, such as SSDs and GPUs, and enabling data center disaggregation. Because the CPU has limited resources that are directly connected to it, PCIe switches are needed to provide access to more endpoints, including SSDs and accelerators, while maintaining low latency between the different endpoints on the fabric. With disaggregation, the need to overpopulate a server with directly connected resources is reduced. A switch network can connect to multiple servers, providing each of those servers access to share the various endpoints connected to it. Peer-to-peer networking is another very powerful benefit of PCIe switches that allows the different endpoints connected to the switch to directly communicate with each other without the need to request permission from the host, thus reducing latency. In the scale-up scenario, multiple GPUs can talk to each other across the switch without having to talk to the host itself. This allows the GPUs to function as a giant GPU to deliver the compute power needed for very large workloads.
The benefits of PCIe switches for AI servers actually break down into two major categories. One is around AI inference. And when you look at an AI inference server, it connects CPUs and GPUs more directly together to provide really high bandwidth data between the two sides. That allows the compute portion to actually pre-process the data. Think of the chatbot that you're talking to. It is trying to give you real-time responses. That pre-processing happens in the CPU. It needs to be tightly coupled to the GPU in order for the GPU to then process the inference data. What that means, though, is more and more lanes on the CPU are being consumed by the GPUs, requiring additional PCIe switches to provide the additional connectivity like the network and the storage. Now, in terms of AI training, things are quite different. In those cases, GPUs require data from the network to pull into high bandwidth memory to do a lot of their processing, and they need that bandwidth to be very high. PCIe switches allow for aggregating a lot of that network and storage data and providing it into the GPU, through the switches into the GPUs. That then provides a very high bandwidth training platform for them to build. Two very different use cases, both of which actually benefit from PCIe switches. Which markets benefit from PCIe switches? One thing that's really powerful about PCIe switches is actually their ubiquity. PCIe switches are found in almost every application in the world today. especially now with AI. They're of course in that application, but they're also involved in vehicles. They're involved in cash registers. That ubiquity actually lends itself to really the powerful nature of PCIe having backwards compatibility all the way from the latest generation, 64 gigatransfers now, all the way down to 2.5 gigatransfers at the original generation of PCIe. This backwards compatibility actually allows customers to build platforms that can be future and backwards proof, providing really long, kind of lasting platforms that can be used in multiple applications. That makes them very applicable in many different places and for long periods of time. And it's really that backwards compatibility in PCIe that has enabled this, allowing servers these days with latest generation GPUs to still be used against current generation CPUs, enabling sort of longer life platforms within the data center.
Switches will continue to evolve with the use of PCIe technology, including in the context of IP, where we are starting to see embedded switches as opposed to standalone switch or separate chips itself. Historically, PCIe switches have been standalone chips that connect the upstream ports to host devices and the downstream ports to endpoint devices. An embedded switch embeds a PCIe switch into an existing product that already has PCIe connectivity to enable access to additional endpoints. An example of a product that benefits from an embedded switch is a SmartNIC. A SmartNIC is an endpoint that connects a server to the Ethernet network and includes some form of DPU to offload network management. Incorporating an embedded switch in a SmartNIC will allow multiple servers to access the network and further allow those servers to access additional endpoints connected to the switch, such as SSDs and GPUs. Deployment of the PCIe switches in the edge is also going to become more prevalent. As we move from training-style workloads to inference-style workloads, where servers need the ability to scale out to either access more endpoints or scale up to compound compute power.
You can learn more about PCIe switches at PCISIG.com.